Hello, and welcome to our virtual roundtable, Military Grade 5G, and Expert Discussion. My name is Nancy Friedrich, and I'm the Industry Solutions Marketing Specialist for Aerospace Defense here at Keysight Technologies. In this roundtable discussion, our esteemed experts will delve into the status of military grade 5G in the US, challenges to success, and future opportunities. Now, let's meet our experts. Robert Wheeler is a retired Major General of the US Air Force and CEO at Strategic Consulting Unlimited. Hi, Robert.
Hey, good afternoon, Nancy. Thank you for having me.
You're very welcome. Dr. Rob Spalding is retired Brigadier General of the US Air Force and CEO of Sempri. Hi, Rob.
Hi, thank you. Thanks for having me.
You're very welcome. Thanks for being here. Dr. Charles Clancy is Senior Vice President and Chief Futurist of the MITRE Corporation and Senior Vice President of MITRE Labs. Welcome, Charles.
Great to be here. Thank you.
Sure. Dr. Ashutosh Dutta is an IEEE Fellow and Senior Scientist and 5G Chief Strategist at Johns Hopkins University Applied Physics Laboratory.
Hello, Nancy.
Ashutosh.
Hi. How are you? Thanks for having me.
Thanks for joining us today.
Sure.
Vincent Nguyen is General Manager of Aerospace Defense Government Solutions at Keysight Technologies. Hi, Vince.
Hi, Nancy. It's great to be here.
Great to have you. And Dr. Raymond Shen is Director of Keysight's 5G and Spectrum Government Solutions. Hi, Raymond.
Hi, great to be here.
Very great to be here. So, very excited to launch the discussion. We will start with a question to General Wheeler. What's your take on where the U.S. is when it comes to 5G for government and military? Are we doing enough?
So, Nancy, I think I would have to characterize that if you're saying, has the government doing enough? Is enough going on in that particular area? As there's a lot of activity going on, but it's a lot of uncoordinated activity. In other words, you're having different agencies going down different routes to build out their piece of the puzzle with no 5G czar per se, who's coordinating it from an overall government perspective. And there's different views on that in that particular area as to what they would do, but I'll give you a few examples. First is spectrum. Spectrum right off the bat is probably the key ingredient to the 5G aspect of it. When you have different ranges of it, you have the millimeter wave, which you see in cities, which has a big giant pipe and low latency, but not a lot of distance. You have mid-band, which you see throughout Europe and in China in particular, and it's kind of a balance between distance and the pipe size, if you will, and how much data you can put through. Then there is the low part of the spectrum, which gives you more range, but not as much pipe. And that particular aspect has been one of them that has caused a lot of the telcos not to be able to move as quickly because they didn't have that. The other aspect to it is to exactly what's going to be the local rules for putting up towers, for doing those kind of localized rule sets. And I'll give you an example right off the bat. Washington, D.C. today, our nation's capital, only has 3 small cells, and it's primarily because the rules of putting up the antennas are so onerous that many of the telcos find it difficult or next to impossible to really move at any type of speed to put those up. So these are areas definitely where the government has a play in trying to help industry move forward on this particular area. And the reason why this is so important, unlike previous generations, there was 2G, as you know, the second generation, third generation, fourth generation, and now the 5th generation. What we're seeing is instead of an evolutionary move, we're really seeing in technology a revolutionary in capability changes. So for example, pipe size, at least 10 times and up to 100 times in certain cases, what we've seen in previous generations. The latency or the delay per se of how much it takes for that particular information to reach a location is at 1/10 of what we've seen in the past. And what does that mean? That means in the Internet of Things, sensors, cars, different areas, that means almost in real time. An example I would give you, if you're on the highway and you're in a traffic area and you have future type unmanned vehicles that are moving down that particular area. In today's 4G environment, it'll take at least 36 inches for all the sensors to talk to each other and actually start stopping the vehicle. If you were to do that same in a 5G environment, it's under inches in that particular arena. So those are examples of how this technology truly is revolutionary, and where it's going to matter is in the military side, but also the economy. So what you see, an example in 4G is Uber. Look at the capabilities that Uber provided in that, and that was because of that incubator that was provided by 4G in that particular environment. 5G ends up being much more, where you can do robotic type surgeries that you could do. We're talking unmanned vehicles, whether that's military on the commercial side. We're talking about factories that can be robotic and moved at much faster speeds than we have before. It allows a virtual reality across the world in different capabilities that we've only dreamed of in the past, to be honest. So all of these are available today with the right infrastructure, which goes back to your question, is enough being done? So again, I would characterize from a government perspective, lots of activity, but not a lot of coordinated activity with that czar, if you will, to put that together. I think that's stymied industry. I truly believe that, because industry wants to move forward on it. They have their own issues because they put in 4G and 3G infrastructures and they're still paying for that. But at the same time, without that spectrum, without the rule set that allows them to understand where they're going to go forward, I think that's one of the biggest impetuses we have right now to moving as fast as the rest of the world. And I do know that some of our colleagues on here will have some strong opinions on that. So I think it's an important point to discuss, especially with the new administration, because there's opportunities to fix that in a rapid manner. Back to you, Nancy.
Excellent. Would anybody else like to jump in and share their opinion on this topic?
Yeah, I can give a little bit. I kind of corroborate what General Wheeler said. We need to really see there is an impetus. We started late. If you look at the previous generation, like 3G, 4G, obviously United States had a lead. But right now we started late, but we have a chance to really catch up. We need to spend more funding in research and development. Things are going in the right direction, but we really need to accelerate that. And that means we need a coordinated effort, at Mr. Willard said, right? We have to see how the private, public sector, private sector, government, universities, they can all collaborate and take it to the next step. That means it's not only standards. We have to build testbed prototypes, make sure actually it works, go back to standards, and ratify the standards if needed, right? So we need all hands on deck at this point.
And Nancy, I just like to say, you know, when the State Department goes overseas and asks our allies and partners not to build out Huawei in their networks, our allies and partners say, okay, well, what's the alternative? And the answer we have is we really don't have a good answer. And quite frankly, that's the answer to your question. Are we doing enough? No.
Nancy, if I could add one more point.
Sure.
I think to where General Spalding is going is a key point. What does the U.S. do very well? And you've seen a lot of discussions on the so-called virtualization of 5G, where you're doing a lot more of software-based type capabilities. That's an area where really government in help could really push that forward. So you're going to see in 3 to 5 years what was hardware today will be in software. And that is what the West does very well. So for ourselves and our allies, it's something that we can focus on to really help talk to what was discussed before about how do we accelerate this? How do we move this? And how do we answer our allies? Okay, not Huawei, what is your solution?
Mm-hmm. Okay.
Nancy,
excellent.
I just wanted to add that as General Wheeler pointed out, there's a lot going on, and what's going on is all a matter of public record, very easily seen. But they call them experiments and experimentation. And I feel like probably if we scale back, do fewer things, but do them really well, and not just call them experiments, but actually commit to it. Add more stick-to-itiveness, which may mean more money. You know, the actual, you know, getting the performance measured and to the point where it really needs to be, like the telesurgery as an example. Really getting that done, that would be tremendous.
Mm-hmm.
Yeah.
Yeah, right now, of course, DoD is one of the big investors in the application space, but the DoD is a small customer in the big scheme of things for 5G, right? They're spending $600 million on their first tranche of 5G base trials and experiments. In my opinion, we need every critical infrastructure sector to be doing similar scale investments. We need the Department of Transportation investing in large-scale pilots of autonomous vehicles and drones. We need the Department of Energy investing in large-scale experiments of smart grid technology using 5G. Right? We need the DHS investing in smart port infrastructure. Right, so DoD is just one small piece of the sorts of investments we need to be making to drive the U.S. ecosystem forward.
That's a great point, Nancy. I just want to add to the point of ecosystem. I see, coming from the commercial comm side, the ecosystem would enable the full-scale build-out of a 5G network in a successful way. So I think that from a DoD standpoint, these tranches are really a great start. But back to General Wheeler's thinking there, I think expand needs to accelerate from an ecosystem standpoint, enable more of the private and public sector to work together and look across the ecosystem.
And so we need a Manhattan type project. We need a Sputnik moment for the nation to move forward. I mean, just taking a look at what we're seeing in different studies that show what the GDP change can be done with a properly put in 5G infrastructure, it varies from 1 to 3.5%. Given where we are in COVID today, a 2, 3, 3.5% jump in GDP would be a welcome at this particular time. So I think it's really incumbent upon the new administration to move forward on this and kind of push on this and have that Sputnik moment or Manhattan type project with industry, with the private sector, and move forward.
Excellent, thank you. So our next question is for General Spalding. It's a bit of a follow-on to, I think, where this conversation is going. So General Spalding, the US, as we said, is putting a lot of money, right, into accelerating 5G. What more can we do to accelerate that progress?
I think General Wheeler highlighted one of the big issues, and that is really releasing more spectrum to industry to allow them to build networks. I think the problem with what the FCC's done to this point, which is to sell spectrum, and a lot of times the spectrum gets sold to bidders who then don't have the money or don't intend to build out the network right away. So I think that's the wrong way to look at spectrum. Spectrum really is owned by the American people, and when you sell a license to a company that really wants to maintain the profitability of that essentially toll road, which is what they have access to, then you really decrease the amount of innovation that happens. And the reason is because the only companies that can afford to pay these enormous bills to buy spectrum in the mid-band, for example, that can pay these billions of dollars for spectrum are the big telcos. And the big telcos aren't in the business anymore of innovating in telecommunications or computing. AT&T doesn't have Bell Labs anymore. In fact, the United States doesn't have a major network equipment provider anymore like they used to. So really spectrum is a key issue. On the defense side, somebody mentioned that they're putting a lot of money into applications. Well, they're not putting any money into platform. And really, when you talk about the applications and use cases of 5G, which is really going to enable autonomy and artificial intelligence at the edge of the network, you're talking about a platform that needs to enable that. Just like the iPhone and Android enabled the mobile economy of today, you need a platform that really enables the applications and use cases of tomorrow. So just paying for, a cool thing that with AR, VR, or some kind of logistics function or warehouse function is great. But if you don't have a platform to build those things on, they're never going to get deployed in any kind of scale.
That's great, thank you. Does anybody else want to add to that? If not, we'll move on to our next question. So Dr. Clancy, what are the biggest security gaps for 5G in aerospace defense?
So at least on paper, 5G is the most secure standard for telecommunications we've ever seen, right? 5G fixes all the longstanding issues that we saw starting in 2G, 3G, 4G. And to a certain extent, at least in this, as described in the standards, is completely secure and hardened, right? The problem is that 5G is such a dramatic change in its underlying architecture that, and it's a cloud native architecture that we've never deployed in a telecommunications environment at this scale before, and it's all new. So while the standards themselves have fixed a lot of the underlying vulnerabilities, the implementations and the deployments are likely going to have vulnerabilities as they begin to be stood up and connected together. So in particular, 5G addressed some of the challenges around privacy for mobile subscribers and some of the encryption issues that we saw between towers and mobile phones that we saw in 4G. It also has completely changed the way that roaming interfaces work between carriers and cleaned up a lot of the insecurities that we saw. But because we still have backwards compatibility, my phone still supports 2G, 3G, and 4G. Bad guys can still attack my phone using 2G technology, even though 5G is much more secure. Additionally, as everything moves to the cloud, right? 5G, that's its whole point, is moving to the cloud. All the vulnerabilities of cloud infrastructure now suddenly become vulnerabilities of telecommunications infrastructure. And we haven't really begun to wrap our head around what all that means and what it, particularly from a security perspective. So DoD has been working on a security profile of how you would put together the nuts and bolts found within the 5G standards to describe its expectations of how you might deploy and configure a 5G network that is secure. We're seeing industry begin to look to that as the initial roadmap. So DoD as an early adopter has a big say in the, I think, the security of the commercial infrastructure because they're the ones who are really they're the impetus for beginning to debug and test some of these interfaces. But again, a lot more is needed in terms of test beds to really understand a lot of these security challenges. And again, it's a whole new regime where the vulnerabilities of cloud suddenly become the vulnerabilities of telecom. And that's going to be, again, the threat surface is much bigger. So, and we aren't even really going to know what all the vulnerabilities are until we begin to experiment with production networks deployed and interconnected. Mm-hmm. Just as a simple example, ordinarily the roaming interfaces between, say, two different cellular networks are very controlled, and there's a lot more touch points for bad things to happen. And again, academically, it all looks great, but in deployment, there's bound to be challenges as we begin to sort through how it all actually works.
And Nancy, the problem with 5G is it's a consumer-grade technology, as is all consumer telecom. And even though it is secure, more secure than 4G, part of the problem is because it's a consumer-grade standard, and because we have globalization where you have authoritarian regimes that are mixing in with democracies, and they see the use of data in a 21st century context as a means to exploit and undermine free societies, then that platform becomes an avenue for attack. We've got a big problem in trying to adapt a consumer grade technology for military use. Now, that being said, the part of the problem and part of the challenge of DoD is that they've been on a completely different, from an IT basis, innovation cycle than the rest of the world. So the ability to collaborate at the speed that the private sector can today is just not, doesn't exist within DoD. At the same time, you have stovepipe, proprietary standards per, in the Air Force, per aircraft weapon system. So the B-2 can't talk to the F-35, which can't talk to the F-22, which are all not problems that exist in the consumer technology. And so it does allow for a standard interface and good interoperability. The problem is it was built for consumer grade products in a world where data is a weapon.
I'd like to add a few things, Nancy, to what Charles said. Let me just share a slide here. Can you see my slide? All right.
Yes, it's come up.
Yeah. So basically what Charles was telling, I just want to highlight that a little bit. I had this slide, I call it pillars, key pillars of 5G and beyond security. 5G as an ecosystem has a lot of enablers like Edge Cloud, Cloud RAN, SDN, and a BSDN controller. Charles talked about microservice. So we have to depend on API-based communication instead of protocols like Diameter that has a lot of drawbacks. I used to work for AT&T Chief Security Office in the past, so I know the SS7 security holes and all those problems with roaming. There are things like network slicing. We talked about virtualization, orchestration, automation. At the same time, if you look on the left side, supply chain security, that's so important. With the introduction of AI ML, how can we do predictive security and data security privacy? So these are kind of some of the pillars. So as we try to take advantage of the 5G enablers, we have to look at what are the additional security risks we have to take care of. At the same time, what are the opportunities these enablers provide us in terms of security? I think so. This has to be really studied in great detail, do kind of a threat taxonomy, end-to-end analysis, and look at the opportunities and challenges for each of these enablers. I just wanted to add that to what Charles said.
Oh, that's great. Thank you. Oh,
Hey, Nancy.
I think you're on mute. Yeah.
Wanted to add to General Spalding's comment about 5G being a commercial grade, and it's so true. But what we're seeing in the industry is that some of our major U.S. primes are looking for ways to leverage what's on the commercial side and make changes to the protocol stack. And whether it starts with the 5-layer or the security aspect of layer 2, layer 3 in the protocol, and leverage that to make it into a more of a bulletproof, scalable solution for aerospace and defense use cases. So.
Yeah, I think the challenge there is making sure we don't break economies of scale in the process.
Right.
So I've been involved in pretty much every generation of mobile technology and how you might add an additional set of features to it that would make it more resistant to jamming or interference. And in every case, you end up with waveform changes that mean you can't use an off-the-shelf chipset, which means you break the economies of scale, which means you might as well be building a DoD radio instead of using commercial. So you have to be very careful about making sure we're using it in the right part of our communications infrastructure, or you lose the whole value proposition.
And Nancy, this is where the problem lies, because if you start to think about the 5G, 6G, and 7G use cases, which are coming down the pipe very quickly, you start to realize that it's a changing world in that aspect. I mean, it's literally going to be a wireless bubble across the whole nation, where every single thing we do nearly that we do on fiber today will be done wirelessly. So robotic surgery, AI, ML, so augmented artificial intelligence, machine learning, big data type informations will all be traveling wirelessly. Very different than a commercial security application for how you would download a movie per se. Or let's just take a look at our highways with autonomous vehicles. That could be catastrophic if you were to end up being able to disenable that capability for autonomous vehicles, or to jam it, or to tell it the wrong information. Another example, of course, would be our electrical power grids and all the critical infrastructure, which all the industrial control systems will be controlled at one point here in the near future on these kind of systems at the 5 and 6G. They can be privatized. They can have different layers of security on top of the security standards now, but we do need to come up with a set of standards, and that is the area that has the most ripe for change that should go. But it's one of the most interesting ways I thought about thinking about this is, if you were to go and look at 5G networks across the world and look at their security and how they apply them, you can actually tell what kind of a nation they are. Autocratic nations, for example, they would use 5G from a surveillance perspective. They would have applications that would allow complete surveillance and understanding of what's going on in the individual person. If you take a look at Western democratic type countries, you're going to start to see a 5G security infrastructure that allows personal privacy, an incubator for ideas and change, where intellectual property can be protected, and basically the rule of law applied to this, because frankly, this is an interstate commerce, an interstate pipe. And I think it was General Spalding that talked about those ones and zeros are no different than the goods of our nation going on our interstate highways today. So that security aspect to it is probably the most critical piece, besides having some help from the government to make sure that we can move forward faster on a 5G piece. Back to you.
Thank you. Okay, our next question is for Dr. Dutta. If being behind in 5G is such a big deal, what are the consequences if we don't get ahead?
Yeah, it's a very good question, right? I think this is kind of a follow-up to what we have been discussing so far. United States obviously should have taken a proactive approach in terms of 5G. If you look at the evolution starting from 1980, when 1G, 2G, 3G, 4G, we had a real leadership role there, right? I was looking at the report by James Lewis from Center for Strategic International Studies here in Washington, D.C. And some of the statistics I was looking at it, if you look at the whole 5G ecosystem, you have different aspects, and you have the end users, you have the radio access network, you have the edge cloud, then you have the core network, then you have the whole application, right? So I think we just discussed that market penetration. Which company within the United States really has a leadership in any of these? Except for Cisco, I don't think we have real leadership there. So we are lagging in market penetration. In terms of standards contribution, I was also looking at some of the statistics. For example, 3GPP SA3, we got only 10% standards participation contribution in the SA3 security working group. Supply chain intellectual property, we're also lagging behind compared to other nations. So these are all the areas we really have to make a headway to get there. So how can we do that? That means, and we started doing that actually. I know I attend some of the working group meetings organized by MITRE in the past, and I have seen there's a big momentum going on there. So we need to have active standards participation in various standards bodies like 3GPP, ITF, Open RAN Alliance, IEEE. Recently ATIS 5G Alliance. We need to be very proactive in the open source related standards like ONF, OPNFV, ONAP, etc. Then we talked about increasing the research funding, collaboration in the area of 5G and beyond, right? And a lot of things are happening both from the DoD side, and SF is building this power test beds where people can go and do prototyping for various use cases, for example, DoD or DHS. We have to be proactive in applying for patents. So our intellectual property, if you compare to other nations, we are even less than 1 million, right, compared to other countries with 5 million patents. Collaboration among universities, operators, vendor companies to develop new technologies, that's important. Then finally, I also like to give importance to things like this. We are doing panel, right? So conferences, workshops. Within IEEE, I'm the co-chair for IEEE Future Network Initiative. We have been doing many of these things like security deployment, different workshops, conferences. So bring people from different verticals on the same platform to discuss different issues. I guess these are some of the things we have started doing it, but there is still more we can do to take a leadership role for 5G and beyond when it comes to 6G.
I think another risk, to get back to the original question about of not getting ahead, is really 6G. So if you look at the 5G technologies, they're all software, they're all virtual. So 6G isn't going to be a bunch of brand new equipment that we bring in and install. It's going to be software updates, it's going to be app updates, right? And if we don't have the leading 5G infrastructure nationally, then we're not going to have the underpinnings to do that software update essentially to get us to 6G. So I've heard a lot of folks saying, well, we're behind on 5G, that doesn't matter, we'll just speed up for 6G. And my response to that is no, you can't do that, right? If you're not in the room for 5G, you're not even in the building for 6G. So we need to make sure that we catch up, otherwise we lose ground that's unrecoverable into the future.
Nancy, I would say that one point that needs to be driven, the strength of our nation is our economy. You know, I'm a former military officer that would be the first to tell you that that is the true strength of our nation. And frankly, if we lose out on the 5G, 6G, and 7G, we're going to lose out on the GDP capability and the strength of our nation and its economy. And that incubator for entrepreneurship, which is so much a part of who we are as a nation, our competitiveness, you see it in our sports, you see it in how we do things in industry. This is that incubator that enables it. It's part of our character. So if we miss out on this, we're going to miss a large capability for us to compete in the world. And I don't think people fully understand that. If you ignite the competition within this country, nobody can beat us. And the changes that will occur for the world are going to be amazing. If you start to think about big data, you start to think about artificial intelligence and machine learning. The answers to many of our world's problems exist in that data today that we just can't get to or enable. That's where 5 and 6 and 7G can really make the difference. And for people that don't understand it, it's not about your movie going faster on Netflix to download to your phone. This is something far beyond that, and it's something critical to our nation's economy and jobs in the future. Back to you.
Nancy, I'd like to add, just from a 6G standpoint, I think, when the time is now. We see that the DoD is jumping on 5G and being all over and funding 5G, but 6G is now. There is so much to do ahead, even allocating, bands for 6G, allocating resources to work and research into the area of channel sounding for 6G, start to look at the use cases for 6G. And that should start now versus let's roll out 5G first, deploy 5G and see what happens.
Hey, Nancy, I just want to add that I think just in this short time, I think I attended a conference 2 years ago in the US on 5G, and they were just starting to roll out these DoD activities. And I think at that point, the people who were attending the conferences who weren't your normal suspects, your usual suspects for 5G, your usual commercial suspects for 5G, those folks really didn't know the first thing about 5G. And in fact, some of them would come up to me and Keysight was already working on 5G, and we were already rolling out these boot camps, and these participants from big name companies would come to us and say, "Oh, I learned so much from your 5G boot camp." That's where we were 2 years ago. And now, what I'm seeing now is that people who are involved in all these activities from a prime contractor point of view, they're so much smarter. And there's so many more applications now, and they're integrating 5G with kind of, I'll call it their normal day-to-day business. And so there's a whole breadth of things that are happening now. And so, so to answer your question, sort of flipped over, it's like there's so many positive things that are going on now that we've had this spurring from the DoD.
Mm-hmm.
Yeah.
It's a great point. It's also a great segue to our next question. Mr. Nguyen, how does 5G in commercial differ from 5G in aerospace defense?
Yeah, Nancy, having the privilege to work with the commercial industry to deploy 5G networks in my past role, fundamentally, I think that there are more similarities than differences. Everyone here touched on the attributes of 5G, so I won't rehash on that. But really, it comes down to the use cases and the ability to leverage the technology and capabilities, including Open RAN, which is a hot topic in recent months. Open RAN, and this panel talked about virtual RAN. The operators are looking at this very carefully and planning and deploying and shrinking their development or deployment cycle significantly, and how the DoD is going to leverage what was done there on the commercial side. So I'd say it boils down to the use cases. Now we know that the 5G technology itself, there's a big promise of ubiquitous high-speed connectivity, right? So there's a paradigm shift for aerospace and defense industry. And when it comes to overall 5G vision for aerospace and defense, the technology itself, it's still in its infancy. So I would say that to bring that to fruition, it would require time. It would require massive investments. It would require the knowledge of the development. The work cycle will extend, right? It's going to be much longer than the commercial comm side. And the reason behind that is the use case of mission critical. When a technology is deployed in a battlefield, lives are at stake. And so the testing, the deployment of really well validated systems will need to be done. And some of these use cases I probably won't go over, but I'll touch up briefly. Internet of everything. They call it the Internet of military things. For example, sensors that thousands of sensors utilizing ultra low latency capability to communicate with network slicing capability. Non-terrestrial, these are things just off my head. Non-terrestrial communication between satellite to ground, satellite to satellite, obviously, but ship to sea. When ship goes out to sea, the communication is needed. Even satellite to the device itself are needed. And so I know someone touched on early on about the different bands, right? As we deploy more and more bands, what are some of the critical coexistence between technologies and between bands? Do we have an agile enough network where whatever band is available, we could hop on? On the commercial side, I would say that area is a bit more relaxed compared to the aerospace defense industry. So the agile network is critical. Device-to-device communication is a big one, right? Drone-to-drone communication. And so all these use cases would require extensive testing, and that impacts the workflow. And the workflow is going to be very different. I think that what I've seen in recent months, really the digital twin discussion is heating up, and the need to simulate in the early research and R&D environment is critical. The network emulation itself then shift over to the hardware in the loop, where the combination between software and hardware for prototyping, for modeling is needed. So again, it touches on the rigorous testing, and that's where you would see a big difference between the aerospace defense industry and the commercial comms industry. So with that, I mean, all this effort will not come easy and quickly, obviously. But I believe that Keysight, with our deep 5G, 6G expertise, we're prepared to help the industry, the aerospace industry, ramp up and accelerate innovation in years to come.
Mm-hmm.
Back to you, Nancy.
Thank you.
I would say that there's a lot of so 5G aspires to support mission critical use cases like autonomous vehicles, right? If you want to support autonomous vehicles, then you need enough stuff baked into the standard in order to support a lot of the DoD use cases. But we don't know how to do the autonomous vehicle use cases either. So it's not as though 5G out of the box is going to immediately solve some of these DoD use cases. There's a long way to go to figure out how to actually build systems to deliver on the other high assurance use cases that are envisioned in 5G.
So
Nancy,
yeah, go ahead, please.
No, go ahead, please.
Now, I just wanted to add the difference, right? When you look at a different vertical, as we discussed, 5G can be applicable to agriculture, e-health, transportation, and in this case, we're talking about aerospace. So it's always driven by an application, right? You have to think about the application, then what are the KPIs needed? What is the environment you are working with, right? Is it tactical networks, nomadic, connectivities? All those things you have to take into account when you design the actual system, right? So I just wanted to highlight that part. Thank you.
I also think an interesting part of 5G is the ability for it to network slice. So on that same pipe, if you want to call it that same data flow, you can have multiple users going through it. So you could have someone who's watching a movie, as we bring that example up several times here. You can also have someone that's controlling an electrical power grid, and you can have someone who's also doing things at the operational level at the military side within the United States or other places. So that ability to network slice is fairly unique to this capability and to secure it. It depends on what you put on top of the set of standards to allow how much you can do there. So if you can imagine you having a commercial company that's going to have government, you're going to have critical infrastructure, as well as commercial use cases for individuals on that same pipe. In the past, you'd have different dedicated pipes for those different things. That's not the way it's going to be today. So that really drives a set of use cases to the point that was just brought up. That's going to make this security aspect of it pivotal, if you will, to how we go forward in 5G, 6G, and 7G. To be honest.
Nancy, I'm not sure if they're that different, commercial and aerospace defense, but one thing that I have noticed is it does seem that the governments, and not just the US, but the governments of the world, seem to be really initiating or spurring on some of the 5G and actually now we're seeing 6G development as well. Some of it may have to do with funding, and other parts of it may have to do with infrastructure that's more owned by the government as well, that wants to be developed or advanced.
I think they're waking up, going, holy smokes, we missed this. We need to move fast in some cases.
Okay, so we're going to take a bit of a break from our discussion and invite Charles and then Ashutosh to show us some use cases. So Dr. Clancy, if you could start. I know that you had something that you wanted to show around 6G, I believe.
So let me, we've been talking a lot about sort of 5G and its abstract features. I wanted to perhaps ground some of the discussion with kind of what are the building blocks that we're talking about. Mm-hmm. So some of the important things to think about with 5G are, one, it's cloud native. So this is, I can't understate the importance of it being cloud native. 4G and earlier technologies were based around fixed function equipment that were put into closets and data centers and did one thing. And if you wanted to upgrade the equipment, you replaced that fixed function piece of equipment with something else. 5G says, well, we as a nation are good at software. Everything is moving to the cloud. Let's essentially almost think about inverting the telecommunications and cloud layers of our telecommunications grid. So ordinarily the cloud was something that sort of lived in the data center. The thing to think about with 5G is the cloud doesn't live in the data center anymore. The cloud lives everywhere. Right? The cloud is in the telco core network. The cloud is at the edge. The cloud is actually at the cell tower itself, right? And then everything is built on top of the cloud. So all of the, and certainly on all the core functions, all of these now are implemented as software, cloud native software, implemented as microservices that run in a cloud environment. They're elastic. They can be spun up and spun down based on demand. And we're now getting to a point where even the cell towers themselves are on a trajectory to become software. There's a set of technologies called virtual RAN, vRAN, that's part of this broader push towards Open RAN or ORAN that's increasingly virtualizing everything. So with 5G, I think we're going to have a lot of the infrastructure virtualized. By the time we get to 6G, essentially 100% of our telecommunications infrastructure is going to be virtualized, with the absence of, except for say the antenna that actually is needed on the cell tower. You can't replace an antenna with software, but pretty much everything else you can replace with software, right? So that's a really exciting trend that we're seeing. So we have a bunch of physical hardware, compute nodes, storage nodes, networking nodes. All of them are completely fungible, and you can glue them together in any way that you need to deliver whatever service you need to. On top of that, you have the control management and orchestration functions of the network. Now that I can build any network that I want, I need all the tools to help me build the networks that I need. And over on the left, you see kind of the three canonical types of networks that 5G envisions being able to build. One is enhanced mobile broadband. So it's just basically delivering higher quality video streaming to your phone. It's making your experience on a smartphone better than it is today, but not dramatically better, because we've already sort of maxed out the data rate needed for delivering pixels to a mobile device with 4G. But the real exciting stuff with 5G is these other use cases. So massive machine type communications, these are large sensor network deployments. Think 1 million connected devices per square kilometer is the design requirements. So logistics, factories, smart cities, imagine just everything having a 5G connection as part of it. The hyperconnectivity of the Internet of Everything. And then you have really more of the mission and safety critical functions, so ultra reliable, low latency communications. So there you have the ability to do real-time communications, very low latency. For example, if I, as was mentioned earlier, if I want to do safety critical messaging between autonomous vehicles that are driving at 70 miles an hour on a highway, I have a very short window of time to deliver a message from one to the other if there's a safety critical event that needs to be responded to. And 5G is designed to handle those sorts of very low latency, very reliable requirements. And that's what really makes it exciting for the aerospace and defense industry, because many of the things that we would want to do in the commercial sector around ultra reliable low latency communications have direct applications to tactical use cases in the military. As does enhanced massive machine type communication supports a whole range of logistical use cases within the DoD, from predictive maintenance to smart warehouses. And then of course, who doesn't want a better, smarter, more secure cell phone? Certainly the DoD has plenty of use for that as well. And so there's aerospace and defense applications for enhanced mobile broadband on top of that. But what was mentioned though is this notion of network slices. So given everything's virtual, everything's composable, everything's elastic, I can build any kind of network that I want. And so that allows me, so what we do is we create network slices, and network slices basically glue together all these virtual resources in an end-to-end way to deliver a particular use case or a service to a device or a collection of devices. So now we're talking about, well, what does a network slice for DoD look like? How might we build that? How might it meet the security requirements that DoD has on their unclassified or potentially classified networks today? How might that work if that DoD phone goes overseas? Could it still get access to those services? All kinds of interesting sort of scenarios you can imagine there. But there's even a sort of bigger aspect to this, I would say, that General Spalding was talking about, which gets to, if I can build a network to do anything I want, I can certainly build a network that it really restricts human rights, right? I can build a network that does mass surveillance. I can build a network that invades privacy. I can build a network that does broad-scale censorship of a population, right? And so that's a major concern as we look at the sheer configurability of all of this. As we look at trends, right, certainly we see improvements in the cloud infrastructure at the bottom. The role of GPUs being included everywhere in the network is unlocking sort of the next big wave of computational advances. The role of GPUs also is critical for enabling AI throughout the entire network. Right, this virtualized control management orchestration layer has millions of parameters to optimize in order to establish a network that will deliver service to a particular class of users. And so the only way to accomplish that in any sort of responsive way is through AI. The network slicing we have today is not very mature. If you were to ask AT&T or Verizon to establish a network slice for you, it would take months to provision given the maturity of network slicing technology of today. But as we move forward, as the technology matures, as we can leverage AI to do more and more and more, these networks are going to be a lot more elastic and demand driven. So the notion being AI is sort of slowly taking over every layer in our infrastructure. The cloud is everywhere, not just in data centers. Everything's going to be built on top of a ubiquitous cloud. And that enables pretty much any use case that you want, because we can now compose the services needed to build it. A good example would be, say, a major sporting event, when we have those again, I guess, where you have 100,000 users all in a stadium. And they all are using a streaming video app, let's say, to live stream aspects of the sporting event. The data requirements of that are huge if everyone is simultaneously pulling that data. But I can actually graft a caching and video compression and video distribution services directly into the network itself, because everything is virtualized. Right? So I can design any kind of network I need for any use case. And this is going to unlock really the next wave of innovation, in my opinion, And it becomes the substrate upon which we start thinking about 6G, and we start thinking about the use cases for 6G over on the left. Things like we're talking about holographic teleportation, among other sorts of exciting futures with 6G. But again, it also fundamentally changes the business models that we see underneath, because essentially we're on a trajectory where hyperscalers own all of the stuff at the bottom, right? They're the ones who are the experts at building out the compute infrastructure. We're already seeing, say, Microsoft and Google and others making huge strides in entering the traditional telco space. So essentially, if the trend continues, the telcos are basically going to own spectrum and subscribers, but none of the infrastructure anymore, which is another interesting trajectory that we're on in terms of the underlying economics of telecommunications. So with that, I could say a zillion other things, but let me, I guess, pause there and I guess hand the mic over to Ashutosh.
Thank you, Charles.
All right, let me try to say a few things here. That was a great presentation, Charles. Yeah, so I will try to say a few things. Can you see my slide?
Yes.
Okay. Let me just. So that was a great illustration, Charles. So I just wanted to highlight some of the 5G and beyond characteristics, right? What you're seeing here, 5G is an end-to-end system. A lot of people think it's just a new radio, just a handset. They don't know what's going on behind it, right? So you have this whole cell tower, Geno D, front haul, mid haul, back haul. You can see on the right-hand side the picture, right? And then you have the whole 5G core sub-business architecture. Then you have roaming providers, Wi-Fi type networks, internet, right? So this is a whole end-to-end ecosystem. So when you start looking at 5G, you really look at the additional characteristics, things like new radio, right? Even in 802.11, they started working on Wi-Fi 7. Obviously they're going in parallel, right? 3GPP is defining new radio, and 802.11, they're going Wi-Fi 7. The millimeter wave, low band, mid band, high band, massive MIMO, densification of small cells, wireless backhaul, etc. Right? So we need to when we talk about use cases, we have to think about how we can take advantage of the additional enablers. So this is on the RAN side. Then as you move right to the core, and Charles talked about some of those, right? Things like software-defined networking, NFV, how to have the orchestration automation, and this is an example of that. When I used to work at AT&T, we started doing this whole SDN NFV. That's the foundation of a 5G network, to make the network more flexible, scalable, adaptive. Charles was giving an example of how to adapt to attacks, make it resilient, or all in a sudden there is a big load on the network. How can you scale up and scale down on the fly? And that's all possible because of things like SDN NFV. Closed loop automation orchestration, how quickly detect something is happening in the network and take the corrective action, right? Mobilized cloud to provide ultra low latency. Network slicing we talked about, how to provide quality of service end-to-end for priority and non-priority type application. We talked about cloud RAN, service architecture. So these are some of the fundamental characteristics of 5G enablers that we can take advantage of. So now, if you put all this together, how is it going to help the end user? So this is just a smart city type graphics. I just give you a short story. Back in 2015, we had the first 5G summit IEEE had at Princeton University, and I was doing a printout at FedEx Kinko's, and 5G, and the lady asked that, so how is 5G going to change my life, right? So end of the day, it is the end user, how they're going to get benefit out of the 5G. So compared to the previous generation, like 3G or 4G or 2G, 5G is not only increasing the bandwidth, it has other aspects, things like supporting low latency type application, massive sensing, massive control. So in this specific picture, as I was telling before, you have to pick an application, look at the KPIs, the key performance indicators, how much bandwidth, how much latency, what kind of massive sensing type happening, and then you design your network. So 5G is going to be all pervasive. If you look at those enablers I talked about, starting with radio access network, edge cloud, etc., is going to be helping us in the smart grids, robotics at home, e-health, intelligent transportation system. So it's various verticals. It's not only the operators who are going to be using 5G. It's going to be private 5G networks. A lot of people are doing that. Even DoD is building those 5G testbed, right, for private 5G network. So you can devise many use cases based on the enablers and then what is happening in the standards, because that is where things happen, right? So if you look at the 3GPP and ITU, so they define these KPIs, right? On the right hand side, you see the ones developed by ITU. Look at the KPIs like peak data rate, user experience data rate, spectrum efficiency, high mobility latency, etc. And they try to put them in 3 different buckets, and that Charles talked about: enhanced mobile broadband, ultra low latency application, massive machine to machine type communication. So once they define the requirement, they hand it over to 3GPP that defines the actual framework. And if you see this triangle here, so depending on specific type of application, whether you need high bandwidth, whether you need low latency, whether you have to support massive machine to machine type communication, you kind of put that in a different part of this triangle, right? And once you determine that, then you design your network. Do you need a edge cloud? Do I need network slicing to support mission critical application, right? So you have all the knobs and wheels to determine once you know the application and the KPIs. And this is something I like. My colleague Gerhard Fettweis from 5G Lab Germany, one of the co-chair, he was with me. So if you look at the dimensions, you have the previous generation had mostly massive content, right? And the increase of bits per second, kilobit per second, megabit. In 5G, we have massive content. At the same time, we have massive control, massive sensing like IoT, and massive resilience. And that's because of SDN and FB type. And when you look at the use case, if you look at the NGMN, they have really defined very interesting use cases. And you try to look at the use case and put them in different buckets, right? And then you design your network. We have things like network operation, where you have network slicing, SDN and NB comes into picture, right? So this is how you have to come up with use cases. I have a few of the examples here, things like IoT, smart transportation, e-health, smart cities, just to name a few, entertainment services, tactile computing, holographic. I think Charles talked about that. And again, you have to look at different verticals, look at the network conditions, whether the networks are, there is a discontinuity in the network, things like in a tactical network, right? Things are moving around. How do you support edge cloud there? How do you make sure the security is not compromised? So some of those things you have to keep in mind as you proceed. This is another example. I like it. This is from Nokia. They put like, you see this, there's a latency axis, there is a bandwidth axis, and there is a system control axis. So you pick an application, let's say in a virtual reality, you need lots of bandwidth. At the same time, you have low latency. On the other hand, if you have industrial automation, that may not need enough bandwidth, but you really need low latency. So if you look at here, some of the application can still be supported using existing 4G network, right? But some of them are not. So that's how you make a determination and come up with a use case, define the application, look at the KPIs, then try to design your network. I'll just leave it there, Nancy.
Thank you. Does anybody want to ask any questions about the use cases and the discussions that we just saw? That was excellent. Thank you so much, both Charles and Ashutosh. We appreciate it. Okay, so the next question is back to General Wheeler. We've been seeing the DoD tranches leveraging 5G attributes in logistics. Are there any other industry trends for the government or aerospace defense market in terms of use cases?
Come off of mute. So there, I absolutely see others. I think that the logistics side is a legitimate way to start because it's a fairly easy way to show how 5G can be used, and it opens the door for other use cases. And the kind of use cases that I can see here is, I think it was talked about, the Internet of Military Things, because of that low latency, because of that ability to take in thousands to millions of sensors. There will be an ability here to have in real time, literally millions of sensors bringing in data. which actually drives you to the next piece for it, which would be edge processing. So we talked about the cloud. If you think about a single ubiquitous cloud, that wouldn't work well from a resiliency perspective for the Department of Defense or for a lot of other agencies given natural disasters, et cetera. So there'll be a series of clouds that connect, and you can think about edge computing, an edge cloud type environment, literally millions of sensors all interconnected, allowing users at the edge in the combat battlefield, for example, or other locations you can think commercially, to be able to make decisions and to reach back when they are able to the larger cloud per se. So those are the ones that I can really see changing the game out there. And there's another interesting aspect. If you think about today's cell phone, the simple cell phone that we carry today, it can be an iPhone, it can be an Android phone. Many of them today have a terabyte hard drive in it. That's amazing. That's more than most laptops in today's characteristic. And many of the chips that are actually in that particular one are in those phones are actually the same as you see in a laptop today. So with this ability to connect very quickly, that low latency we talked about, you also have the added capability to suddenly have disaggregated supercomputing. So in other words, I'm connecting all of these very capable smartphones in various configurations that's fungible, just like Charles talked about before in the virtualization piece, and build out edge processing and supercomputing at the edge by connecting all these systems together in real time. So there are so many applications that the DoD can play with here, and logistics is just the beginning. And frankly, as we move to 6 and 7G, I think we're going to become much more mature in these areas. Back to you.
Yeah, and I would just sort of reiterate, I think, a point from earlier on, which is look at the amount of energy that $600 million of Tranche 1 investment from DoD has created. Imagine $6 billion worth of investment across every critical infrastructure sector and the amount of energy that that would drive, right? I mean, it would be huge, right? So I think we've proven that, and then of course, the DoD Tranche 1 use cases, I doubt DoD is going to get any like real acquisition value out of any of these things. But what it's doing is it's helping the domestic 5G ecosystem grow up so that down the road they can acquire these sorts of services commercially from these vendors. But again, imagine if you did that in 10 other critical infrastructure sectors as well, the amount of progress we could make as a nation.
Think about what that would mean to the economy, really. I mean, the ability that we could leap here for the economy, it's incredible, to be honest with you. I think it well surpasses any of the studies that were done by very good groups. If it did exactly as Charles just said, if all the infrastructures, the critical infrastructure groups were to put that $1 billion+ in there and really work on these problems and develop these capabilities and then cross-pollinate from there, we could really take this to a new level.
Okay, General Spalding, what direction do you see new use cases taking?
Well, it's kind of like you know, the iPhone. You know, you had to have widespread consumer adoption of the smartphone before you could have the introduction of the App Store, which then really showed the power of the device. You needed a network to go along with it, of course. But so, I mean, part of the problem with applications and use cases is the lack of a platform is really slowing down the ability to implement those. And as opposed to consumer adoption for 4G and smartphones, 5G really requires community adoption. And part of the problem is, how do you get the community to adopt a technology that is for the community? It is a consumer grade technology, but it's not a consumer technology. It is a community technology, because it's really not about the smartphone. It's about the smart city. You know, when I was a senior defense official and defense attaché in Beijing, I loaded up my smartphone with all the apps that you could use, but it was only partially a smartphone world at that time. It was kind of a step between 4G and 5G, so you could order food on your phone, but then walk into a restaurant and never touch your phone again, because the camera would recognize your face and the server would hand you your food and greet you by name. So that's the 5G world. It's really about using biometrics to authenticate for point of sale transactions. that is when we're really going to see, the power of 5G is when it's really deployed as a community infrastructure. And until that time, everything that we talk about and think about 5G is pure speculation, because we don't know what that's going to be until we have widespread community adoption.
I just like to add one thing there. Talking about new use cases, sometimes we have to be also a little innovative. That's part of the roadmap, right? Within IEEE Future Network Initiative, we're defining roadmap like 3 year, 5 year, 10 year from now, how things are going to look like. That means you have to kind of be visionary to define the KPIs. I think the ATIS Next Year Alliance is trying to do something similar, right? Where you have to think ahead of time. It's taking maybe 10 milliseconds now, can you reduce it to 1 millisecond? And if you have to do that, what are the applications you can be supported? So that visionary innovation research has to happen. That's where we really need collaboration among the government, industry, and universities. And of course, the standards bodies like ATIS, 5G Alliance, 3GPP, IEEE, etc. Yeah.
Yeah, I think the sparks of new use cases is going to fly back and forth between the commercial and the aerospace defense industry. I mean, it's going to drive more and more innovation on one side, perhaps in one area, and it's going to spur more growth as more and more technology and use cases are leveraged, whether it's in military or aerospace and defense. So I would say majority of the use cases, perhaps, we don't know what we don't know today. Until 5 years from now, we'll see that, boy, it's going to expand greatly.
Absolutely.
So, Dr. Clancy, should military and government agencies be concentrating on 5G when the commercial industry is already moving on to 6G?
Well, I mean, I think I wouldn't say commercial industry has moved on entirely. There's still a lot of work to do to develop, finish the standards, develop the products, deploy the products. But yes, the R&D side of industry and certainly academia are starting to think about what 6G might look like. And so if I may, let me just share a little diagram here. We talk a lot about key performance indicators or KPIs. And so you can kind of look at this trajectory from 2G to 3G to 4G to 5G. And we can start to think about what sorts of network performance we might see with 6G, right? So with 6G, we're seeing 5 to maybe as high as 100 gigabit per second sorts of data links, right? With latencies now under 1 millisecond, and with densities as high as 10 million or more devices per square kilometer, right? We don't really know what use cases those are going to translate into, right? As General Spalding pointed out, we didn't know what the App Store was going to mean for the social mobile internet until we had the iPhone and it was widely adopted. But what we can do with 6G is start thinking about what are the key performance indicators, and then this leads to two discussions. If you can accomplish these sorts of rates and latencies and densities, what use cases are now possible, right? And Ashutosh had that great chart that showed sort of rate and latency on two axes, with the gray box being all the 4G use cases, the white box then being the 5G use cases. Now, what's the 6G use cases that are going to wrap around the next layer? I don't know that we know yet, and I don't know that we'll know until the technology's here and we begin developing it. Otherwise, it's all kind of just speculation. Like you said, a holographic teleportation is the one everyone talks about, but who knows if there's going to be a market for that 10 years from now. So the other thing, though, is what are the laws of physics we need to bend in order to actually accomplish the next order of magnitude improvement on each of these axes? There are fundamental new approaches we need for spectrum if we want the bandwidth needed to accomplish these data rates. 5G is pushing our current spectrum policy regulatory regime to its breaking point, I would say. And there's a bunch of band-aids that we have and a lot of incompatibility. Even the most recent FCC order around 3.45 to 3.55 gigahertz and the auction associated with that is establishing a whole new approach to spectrum sharing, different than all the other approaches to spectrum sharing that we already have in adjacent bands. And so as we move to 6G and need an order of magnitude more spectrum, it's not sustainable with the approach we have now, right? So there's a lot of work to do to figure that out. Latency, again, getting further down to the latencies we're talking about for 6G will require things like, I don't have the luxury of converting bits from photons to electrons and back again, which is how our current systems work of data moving over a copper cable and then going into a switch or a router and then into a fiber optic link and back out again, right? So we need all optical switching and routing and breakthroughs in order to get the latencies down to these numbers. We start to become limited by the speed of light. If we want to achieve these latencies and we assume no delay in any of these optical to electrical conversions, we assume everything happens instantaneously, we still have, the computation can't be more than 30 kilometers away from the cell tower, or we can't make these round trip times at the speed of light. So again, there's some really interesting physics problems we're going to come up against as we continue to push the key performance indicators and move towards 6G. So 100% we should be focusing on 5G and working on deploying and operationalizing 5G. We also can't take our eye off the ball with the R&D and requirements for 6G. And I think, in fact, the DoD initiative led by Joe Evans is sort of structured that way, where it has the multiple lines of effort, and it includes one that's starting to look at some of the 6G activities. And as Ashutosh pointed out, the ADIS Next G Alliance is kind of ground zero for this discussion right now in at least in North America. There are similar forums happening in the EU, in South Korea, and in China. All of them trying to inform what ultimately will be a set of requirements that come out of the UN through the International Telecommunications Union with IMT 2030. So at least on the research side, there's a lot of activity now starting to think about 6G. But again, can't lose sight of the fact that we've only scratched the surface in deploying 5G.
I kind of agree with Charles there. 5G is still in the midst of deployment. There are lots of challenges we still need to take care of. At the same time, as researchers, innovators, technologists, we need to really spend time and effort to do some work in 6G so we don't lag behind. And ADIS Next G Alliance, I've been within IEEE, the Future Network Initiative, we started looking into some of those.
I think I'll add one point, and is kind of reinforcing something that was said earlier. The infrastructure changes that 5G required are going to support 6G. So by moving strongly on 5G, you're actually supporting 6G. So in essence, we can't forget that particular aspect. If we don't invest in 5G and we don't put that money against it right now, we won't have the infrastructure to do 6 and 7G. And that's clear cut.
Okay, Dr. Dutta, what is Johns Hopkins APL doing today in terms of 5G projects?
Okay, I have some slides to share. So a lot of interesting things happening, right? I'm going to give a sample. You can hear me?
Yes.
Okay.
And we can see the slides.
Sure. So we have a lot of projects happening. We call it IRAD, the Internal Research and Development. But these are some of the funded projects. Again, this is on clear slides, so I wanted to make sure you see that. So primarily, I'm focusing 2 sponsors here, but we have other sponsors. As you said, DoD has taken it real seriously, right, and spending a lot of efforts with Dr. Joe Evans and other OUSD. Many of them are test bed related. If you see, we are also spending some effort on standards like in 3GPP. I personally have been involved in ATIS, Next G Alliance, and IEEE Future Network Initiative. There's a tactical radio stuff we are building with 5G cellular capability. We are working with DSO on the spectrum sharing study. This is I don't know if you have seen this cold stuff, cell and light truck. You really have a portable 5G and in a truck you move around. So this will be a very interesting experiment in a practical environment, how to communicate between different moving 5G systems, right? I don't know if you come to APL at some point, we can show that to you, or you can even see some of the trenches. And I'll give some example of the resource. We also recently, last 1 year or so, maybe 2 years, DHS have been interested to see how they can take advantage of 5G enablers. technologies, right? So we had a three-party collaboration with NSF, DHS, and APL, where we look at DHS use cases, try to see what are the pain points they have with 4G, and then try to do the experimental work in powered testbed that's designed by NSF in core places. And there are some wireless priority service. We started working on 4G, then moving into 5G. And this is where I think MITRE also working on this. So I'll just give one example just to show one specific use case. There are several different lipstick use cases for DHS ads. And we started looking into active school shooter scenario and see how some of the pain points they had and how 5G enablers can help take care of those pain points, right? So let's look into that. So we had about a year or two back, we had a drill on active shooter scenario. And you see on the left-hand side, these are some of the pain points they had in terms of latency, congestion, interruption during handoff, bandwidth problems, complexity in setting up the video stream, etc. There are lots of problems they had, and then we said, well, you have these pain points. How can 5G enablers help fill the gaps, right? Or performance and operational gaps. So I'll just give two examples. In one case, they were sending this video, it's taking like 7 seconds, streaming video that needs to be reduced. So here we try to see how we can take advantage of the edge cloud and provide real-time communication and reduce the communication delay, right? The second one, I'm going to show example, and we actually did prototype in our test bed, and now we are in the process of bringing in the power test bed. As the incident unfolds, surge in number of calls and data traffic from incident scene contributed to the network overload. That means started with one phone call, then becomes hundreds of phone call and video data traffic. So can we take advantage of software-defined networking and network function virtualization to help scale up the network, right? So, and I'll give some example of that, how actually we did that. So let's take those two examples. So example here you are actually applying the orchestration, automation, and edge cloud, right? So here, this is the active shooter scenario, and how we are reducing the delay, right? So what happens is initially when you start sending the video is going over the 5G core, going to PSAP, and then getting distributed to rest of the folks. So it's taking almost 10-second delay for the video distribution. So we have to reduce that. That means if you see, you have the data analytics there, it's taking 10-second delay. So we see that we really need to reduce that. That means we have an opportunity to add edge cloud on the fly near the incident scene, right? So we have this user plane function. We instantiated the edge cloud at the edge. And by doing that, we are able to reduce the whole distribution to 5 milliseconds. So this is one advantage of using the automation, orchestration, and edge cloud, and brought the KPI down from 10 seconds to 5 milliseconds. So that's one example of how we took advantage of 5G enablers for the fast responder community, right? So second one is closed loop automation and active shooter scenario. So this is where if you see initially one call goes maybe a few bits per second, kilobits per second, then all of a sudden people started calling, started sending video, lots of call go over the 5G core, and there is a congestion at that point, right? So can I, as Charles was telling, right, we have virtualization. So we take advantage of the virtualization and software-defined networking, and we actually start instantiating more user plane function or AMF, which is the signaling function at that point, and we instantiate provision this dynamically. So at that point, we scale up the network based on the demand. At that point, the quality of service is actually maintained, right? So that is a second use case. We were able to do that in our lab and provide the quality of service. The fast responder community, in that case, they don't have to compromise on the quality of service. The third one is network slicing. I think there was some interesting discussion around that. So the slicing helps you to provide end-to-end quality of service depending on the type of application. So in this case, I'm showing a mission critical application, non-mission critical application, right? So we can really set up the slice and re-provision the resources for a specific slice and make sure, let's say in this case, a mission critical application gets enough bandwidth, enough computing power, enough memory end to end. So I just saw like 3 different examples, and then finally, while we did all those things in our lab at APL, we are part of this NSF Power Consortium, as you see here, one at Columbia University, Salt Lake, this in North Carolina State University, and they recently announced, I think, Iowa State, they got this rural broadband communication. So we have connectivity to all these test beds. So we do a simple prototype and then take it to those power test beds to do a wide scale scalability and feasibility study. So this is a good way to look at the requirement of a specific sponsor, a DHS or DoD, do it in a lab, and then go out and make use of this test bed like power test bed or any other. I mean, DoD is also working on that. And I just want to leave with this. It is so important while we are doing all these prototypes to get involved in many of the standards bodies. I'm showing a sample of that to build the actual prototype, look at the requirement, look at the enablers, put them together and build it. And if something doesn't work, go back to standards and ratify that. This is just an example of this test bed, what we are doing, very much involved in that. I would encourage anybody listening to this panel should really try to take advantage of some of these public-private partnership we have. Yeah, I mean, this is kind of my summary takeaways. I just wanted to I strongly believe that test bed prototypes are important, standards are important. If you don't build a proof of concept, you don't know what is lacking. So we have to work with companies like Keysight, other prototypes, vendors, and build them together in the lab, and then use the big test beds like Power or DoD trenches, because lessons learned from that will help us to propel 5G deployment, at the same time look into 6G. And finally, the research standards test bed collaboration among local, state, and federal partners is very, very important, because that will help to accelerate the 5G deployment and dive into 6G development. I'll just end there. Thank you.
Thank you. Does anyone have any questions or comments? Okay, Dr. Shen, looking at the security concerns for 5G, which of course we've covered in some detail already, how is what we do different for 5G in aerospace defense? Is there anything you'd like to add?
Well, security is a concern for everybody, whether you're aerospace defense or commercial. But I think in the aerospace defense land, I would say security is their middle name. I mean, on day one of a new job, you're ushered into a secure facility and told how to operate and what you're supposed to do and what you can't do. And so, by de facto, there's almost more of an emphasis on security within the sort of aerospace defense environment. And so I think, in terms of 5G security, the aerospace defense land may look at it sort of every which way, offensive, defensive, sort of looking at any kind of attack possible, whether it be fuzzing, denial of service, distributed denial of service, man in the middle, jamming, anti-jamming, malware insertion, et cetera, and so and like I said, they'll do it. We may be more involved with that from both sides of the equation, sort of offensive capability, defensive capability. How can you attack a network, or how can you defend a network? I think that the interesting about Keysight is that you wouldn't think of us as a security company, but actually we have many tools that can be used for security, and also over the RF network, as well as the Ethernet network, the transport network.
I just like to add one thing there. I have used Keysight's tools when I was in AT&T also, and even where at APL we have been using. This is so important to have the ability to emulate different kind of threats in the lab. Unless you do that and generate different types of loads, So when we build a test bed, having tools like emulation, simulation tools are so important. Otherwise, you cannot just scale and try to deploy things. So I just wanted to highlight the importance of having this kind of tools, which are so important to realize when attack happens, what kind of attack happens, how quickly I detect and mitigate, right? How do I do this closed loop automation orchestration? Look at that data analytics.
Okay. Does anybody else have any closing comments before we end this session? This was wonderful. I'd like to thank each of you for all of your contributions. I've learned a lot, and I'm sure our audience has learned a lot as well.
I'll just add one point where we started, Nancy. I do think that what you saw today is the potential here for how important 5G is to our nation from an economy perspective, from a military perspective, and just for the creativity of who we are as we go forward. And that's going to take some leadership. I think we heard Charles make comments about we need to invest in the different critical infrastructure areas, how that could light this off in this particular area. We've talked a lot about the security aspect, especially in the non-commercial environments. We didn't talk a lot about, but critical to deployment is the local aspects of being able to deploy towers and putting those smaller towers up in 5G. That is an impetus or an impediment, I should say, to many of the locations throughout the country. And finally, the spectrum piece. It's going to take leadership on the government side. It's going to take that particular aspect to step in and to have those public-private partnerships and to kind of bring all the different agencies going in different directions together and lead the nation towards 5, 6, and 7G leadership where we were in 2, 3, and 4.
Yeah, I guess I would say I think it's important to think about DoD and defense and aerospace as it intersects with 5G as more than just the opportunity that 5G brings to the DoD from a use case perspective. We also need to think about the economic impact that 5G has on the nation and how that is intertwined with our national security. So while it gets back to sort of how DoD's and my comment about DoD investing in 5G and that probably not having a direct path to some DoD acquisition program. I think it reflects sort of a future mindset of how DoD needs to work with technologies that are unfolding in the commercial sector and where the economic equities of our nation are intertwined with our national security and our emerging technology interests. So I would expect to see this same sort of activity in everything from quantum computing to AI to semiconductors as really how we think about the defense investing at scale and in innovation.
Yeah, very good point, Charles. I definitely resonate with everything you said there from a cross-technology standpoint.
Okay, well, I would like to thank all of you for your participation. This ends this part of the event, and thank you. I look forward to speaking with you again.
Thank you.
Thank you, everyone.
Thank you, Nancy.
Thank you.
Thank you. Take care.
Thank you.
Thank you, Nancy.
Bye-bye.